So here in this video, we're going to look at an algorithm and then determine what the big O estimate of that algorithm would be. So here's what we're going to be looking at, and there is a link to the Python tutor code for this in your notes. But before we do any big O analysis, let's just kind of talk through it and see what this is saying. So I'm defining a function that I'm calling polynomial that takes two inputs, C and A. Now I have some comments in here so we can kind of understand what's going on. C is going to be just a float, and A is a list of n plus 1 floats. Now let's skip down here to the second comment. Ultimately, we're going to have a Y, which is going to be, now notice this looks a lot like a polynomial, okay? As a matter of fact, if I write this in more familiar notation, it's going to look like this. Y equals an c to the n plus a n minus 1 c to the n minus 1 plus down to a1 times c plus a0. This is the expression we have for a polynomial that is evaluated at c. So what I mean by that is you could take something like y equals let's see, y equals 2x squared plus 3x plus 1. And then if I want to evaluate that at x equals c, that would be y equals 2 times, actually, let me use an actual number here. Let's say, let's use 1 for c. So this is going to be the number 1. So this would be 2 times 1 squared plus 3 times 1 plus 1, which would give us 2 plus 3 plus 1, which is 6. So that's what this algorithm is doing. It is taking as input a c, which is where a polynomial will be evaluated, and then a is a list of the coefficients. Okay, so I'm going to start out by defining power to be 1 and y to be a0. Now a0 corresponds to this term right here. That is the constant term of the polynomial. And then the power is going to be the power that the c term gets raised to. So since the constant term of the polynomial doesn't have a c, it's not multiplied by c right here, that's why this is just left by itself. So then what I do for I in the range of 1 to the length of a, that is, I'm going from this term here all the way to this term. That's what this for loop is doing. It's going from here to here. I'm going to redefine power to be power times c. In other words, I'm taking higher and higher powers of c. And then y is going to be whatever y was defined as previously, plus this coefficient term times the power. Okay, now I'm not going to do this, but it would be very, very good practice for you to take a simple polynomial, like this, and try to follow through this algorithm and see how it gives you that output. That would be an excellent exercise for you to practice, okay? So once we go through this algorithm, we're going to get y, which is equal to this, and then I'm going to return y, and y is the value of the polynomial, and I guess I should probably add in here the value of the polynomial evaluated at c. All right, so now that I've given a little bit of explanation about what this algorithm does, let's see if we can figure out what big O of this algorithm is going to be. All right, so here is all that without all the writing a little bit cleaned up. Let me resize this a little bit, move it up here so we can kind of talk about what's going on. Okay, now I want to point out real quick that operations for us are going to be additions and multiplications. Okay, that's what our operations are going to be. All right, so So we start out in the algorithm by defining a variable, and then we have a for loop. So what happens inside that for loop is for each I, we have, first of all, a multiplication. So we have a multiplication. That's going to be one operation. And then we have an addition. It's going to be one operation. And then we have another multiplication. It's going to be one operation. So altogether, for each I, we have 3 operations. Now, how many i's do we have? Okay, well, I is going to run through 1 to the length of a. Now, we said that a is a list of n plus 1 floats. So if I go from 1 to the length of a, that means that there are, so I is going to range over n variables because I'm going from 1 to the length of a. The length of a is n plus 1, but I'm not starting at 0. Okay, I'm starting at 1. So I'm going to have n variables. So that means I'm going to have 3n operations. Well, remember when you're doing big O analysis, these constants in front, they don't matter because of how the definition of big O works. So if we don't worry about that constant, that means this algorithm I'm calling polynomial, this has, so the algorithm is, and I'll use a different color here to emphasize it, this algorithm is big O of n.